Okay, this is Chapter 1, Introduction, Part 1. I've broken this talk up into a couple of parts just to make it more digestible. So we're going to start with a little bit of housekeeping, basic definitions, talk about renewable energy and non-renewable energy. And then I'll get into the sort of the heart of the talk, which is energy use patterns in society. And I'll go through some of the very high-level national and worldwide energy statistics, talking about what kinds of energy we use and how we use it, what we use it for, and why we use so much energy. So read Chapter 1. The assigned readings are pages 1 through 30. Of course, this is the textbook here, Heinrichs and Kleinbach. Now, one of the things you'll find when you read the textbook is that it has a focus on the USA. It's written by US authors, and the book is marketed to the United States. So you'll find a lot of the statistics are for, well, some for the world, but whenever it goes national, it goes to the USA. So I will be providing throughout this talk and throughout the course sort of comparable statistics for Canada, and I'll point to where you can find more of those. So one of the things you should keep in mind as you're reading the book, because it's so USA focused, is you should think about how is the US energy situation different from that of Canada. And they're vastly different, actually. And I've listed a few of the main points here. One is that Canada is an energy exporter. We're energy independent. We produce energy and we export about a third of our oil production and about half of our natural gas production. And our biggest customer is the United States. So we're a stable, sort of politically stable supplier of oil and natural gas and a little bit of electricity to the United States. Of course, we all know that Canada has the Alberta tar sands or oil sands. And these are very large reserves of, low-grade petroleum. And we'll talk about those later in the course in some detail. In contrast, the USA is an energy importer, particularly oil. Their economy historically has been vulnerable to the oil supply, the worldwide oil supply. A little bit less lately because of the developments in fracking. There's fracking for oil, and they've been developing their oil supply in the United States a bit more. But one of the key issues in the past, when I was a teenager in 1973, there was this thing called the energy crisis, the OPEC oil embargo. Oh, by the way, OPEC is the Organization for Petroleum Exporting Countries. You'll hear it if you listen to the news. It comes up a lot. This is sort of a cartel of mostly Middle Eastern and North African countries that attempt to control the supply and price of oil worldwide. There's a little sidebar in the textbook on OPEC on page 22. So have a look at that. So what happened in 1973 is there was a war in the Middle East. I think it was called the Yom Kippur War. And it was with, I think, Syria and Egypt attacking Israel. And the USA stepped in to supply arms to Israel. And in retaliation, OPEC embargoed oil. They prevented oil from being delivered to the United States because they needed it for their economy. And pretty much overnight, the price of oil went up by a factor of 4. Now, this doesn't cause a huge problem in Canada. Of course, the price still went up. Oil is a worldwide commodity. But in the United States, there was huge shortages, particularly of gasoline and diesel. And so there were lineups at gasolines and gasoline rationing. It caused an enormous impact on their economy. So that's sort of it constantly echoes through it's echoed through history since that time, with the U.S. attempting to achieve energy independence and taking on, probably conflicts in the world to protect their oil supply for their economy. I think that's fair to say. Another difference is the way we get our electricity between the United States and Canada. In Canada, we have large hydroelectric resources, so energy from water power. About 60% of our electricity comes from water power. In the United States, I think it's something more like 15%. And we don't burn a lot of coal in Canada. We have phased out coal in Ontario, and there's still some coal out west. We'll talk about that. But we burn a lot less coal. In the United States, they get about 40% of their electricity from coal. Now, why is coal a concern? Think about that for a minute. You might pause and think. Of course, the first thing that's going to come to your mind is climate change. And that's true. Coal has a high carbon intensity. It emits a lot of carbon dioxide. It's a fossil fuel, so that's certainly true. But one of the things I want to emphasize in this course is it's not just climate change. Coal creates a tremendous amount of air pollution. We'll talk about it in the air pollution section of the course. It emits particulate matter and sulfur dioxide. So those are a health hazard to humans. In addition, the sulfur dioxide goes up into the atmosphere and combines with water to produce acid rain and destroys our northern lakes. Furthermore, most coal has at least some natural mercury content, and when you burn it, it vaporizes and creates atmospheric mercury, which is a neurotoxin. And in addition, the coal mining industry has been tremendously unsafe. The safety record in the United States and worldwide for coal miner deaths, per unit of energy delivered is really quite horrendous, and we'll talk about that. So coal has a huge downside in addition to the climate change issue. So one of the things I'm going to be doing in this course is every once in a while I'm going to interject a slide that I call In the News. It's sort of a recent news item that has something to do with energy and the environment. Sometimes I'll fit them in where they make sense in the course. Sometimes I'll just fit them in because it's what's going on in the news that week. And this one is from January of 2009. It's about the federal government reaching an agreement to phase out coal in Saskatchewan. Now, the federal government wants to phase out coal in Canada by 2030. This is part of our sort of commitments to dealing with climate change. And currently, for example, in Ontario, we don't use any coal at all. Coal was phased out by the Liberal government in 2014, but we still burn coal in Canada. We still burn it mainly in Saskatchewan and in Alberta. And currently, Saskatchewan gets about 50% of their electricity from coal, which, as I just spoke about, is not a good thing. And so Ottawa reached an agreement to phase out coal. And as part of that deal, is kind of interesting, is that Ottawa agreed to fund a geothermal plant. So a plant where you take heat from the ground that generates steam to generate electricity. And that'll be Canada's first geothermal plant. If you end up doing the course report on geothermal energy, you might want to look into that, what the status is on that. Okay, now just a little bit of housekeeping, really. I just wanted to do some definitions right at the beginning of the course, talk about non-renewable and renewable energy sources, which you probably have an intuitive sense of. Of course, non-renewable energy sources are things like fossil fuels, coal, natural gas, and oil. In theory, they could be renewed by the Earth, but it's on the time scale of 100 million years or so for biological matter to get converted into coal and natural gas and oil through geological processes. So for any reasonable sort of human civilization timescale, it's non-renewable. Another non-renewable energy resource is uranium ore, which is used in fission power plants, nuclear power plants. We're going to talk about that. There's a large resource of uranium on the Earth, as there is fossil fuels, but nevertheless, it is a finite supply and non-renewable. You might find this interesting, that there are actually only three sort of fundamental sources of renewable energy. One of them is solar energy. And as I've pointed out here, things that we traditionally, they are renewable energy: wind, hydropower, ocean waves, biofuels, burning wood, and things like that. They're all renewable sources of energy, but they all have their root in solar energy. The sun drives the hydrological cycle, which drives the water turbines, for example. Or the sun powers, supplies the energy for plants to grow. So you've got solar power. Another fundamental source of renewable, which stands on its own, is geothermal power. This is sort of heat inside the Earth, and it's created primarily by the decay of long-lived radioactive elements like uranium and thorium. We'll talk about radioactive decay and how it produces heat when we talk about the nuclear fission part of the course. And of course, that heat is used to heat groundwater, which put through a turbine to make electricity, or you can pipe it directly to houses to heat homes, which is what Iceland does. They get a huge amount of their electricity and home heating from and building heating from geothermal power. That's also a course project, by the way, course project topic. And the final source of renewable energy that stands on its own is tidal energy. And this is the energy that's produced by the gravitational interaction between the Earth and Moon. It causes the sea level on the Earth to rise and fall twice a day. We have a tidal power plant in Canada. We have one in the Bay of Fundy. I think it's called the Annapolis Power Plant. And this is another, tidal energy is another course project topic. So you might want to look that up. Canada's role in tidal energy. I think there's a couple of other tidal power plants around the world as well. And so in this next section, I'm going to be talking about energy use patterns, both nationally and worldwide. So, of course, energy has many forms, and we're going to talk about the physics of energy, electrical energy, chemical energy, kinetic energy, that sort of thing, in the next section or in a subsequent section in this course. For now, I just want to focus on sort of how we use energy and why we use so much energy. The amazing thing is how integrated energy is into our modern lifestyle and our technological society. You think of everything we do that requires energy, transportation of people and goods, making things, industrial processes, our manufacturing systems. In our buildings, residential and commercial buildings, we have domestic hot water. We have to heat the buildings. We have appliances, so we have, electrical supply to the buildings. So there's electrical generation is a large consumer of energy in society. We use it to plow the fields for agriculture, for harvesting. We use it to supply water and to treat wastewater. We use it for things like mining, so resource extraction. So energy really does pervade all sectors of our society and our economy. And it's one of the reasons why it's been so hard to deal with climate change, is because it's really strongly integrated into every aspect of society. And of course, right now, most of this energy supply is coming from fossil fuels. And we'll talk about that later in the course. So I've written here, the typical North American uses 6 times their fair share of energy. And of course, not just energy, but material resources. And I've listed Canada's imbalance here. This is from the EIA. This is the Energy Information Administration. That's a department of the U.S. Department of Energy, and they maintain statistics for energy use around the world. It's an amazingly good site. There's also the National Energy Board in Canada. That's the equivalent organization in Canada. And so I've listed here, Canada's population may not be completely up to date, but we have about 0.5% of the world's population, but we use about 3% of the world's energy, so about 6 times the average. And so we use around 14 QBTU. Don't worry too much about that. QBTU is quadrillion British thermal units. A British thermal unit is a unit of energy, and the Q stands for quadrillion, or 10 to the 15 if you're comfortable with scientific notation. And of course, the reason we use so much energy is strongly linked to the fact that we're affluent and we have fairly lavish lifestyles. So next, what I'm going to do is go to a landscape slide. So because sometimes I'm stuck, I don't want to have a portrait slide, a landscape slide. I need to be able to show a broader slide. So I'm going to click on this, go to the landscape slide. Okay, and this is a chart that shows the number of people per car, the number of people per television, and the percentage of income spent on food. So you're sort of a measure of your disposable income for various countries: India, Kenya, Japan, Brazil, and Germany, USA. And I've listed here, I've just added Canada here because Canada's energy use patterns and standard of living are very similar to the United States. So you can see the huge variation in sort of affluence. And you can imagine that, if you the more people you have per car, the less energy you're going to use. And so affluence and energy use and the subsequent environmental impacts, which we're going to describe in this course in detail, are strongly linked together. And your textbook makes the point, if you read the chapter 1, that a lot of the developing countries they're striving to become as affluent as North America, and a lot of the energy usage, growth in energy usage, is going to be in those developing countries, and of course that's going to involve a growth in environmental impacts as well. And I note here that when the time I looked this up, China was about 600 people per car, but they're rapidly changing that. Okay, now I'd like to talk about energy use patterns at a very high level. Don't get too hung up on the detailed statistics. Just take away the broad patterns from this. This is a pie chart showing the Canadian energy consumption by fuel type. Again, this is from the EIA, Energy Information Administration in the United States. And you can see the broad categories of fuels that we use. We use a lot of oil. About 31% of our energy comes from oil. We use a lot of natural gas. Oil is used primarily for transportation, a little bit for power generation and backup generators, but mainly for transportation. So, that would be gasoline and diesel fuel and some aviation gas for the aviation industry. We use a lot of natural gas, and that would be for electricity generation with gas turbines. We'll talk about how gas turbines work later in the course. In Ontario, we heat a lot of our homes with natural gas. And of course, we power industry, boilers and things in industry. Now, the remaining ones here, coal, nuclear, non-hydro renewables, and hydroelectricity, these are all electricity sources. Canada has a large amount of hydroelectricity and some nuclear. Most of our nuclear is in Ontario, and we still do use some coal-fired electricity generation, which as I spoke, we're trying to get rid of. So if you add up Canada's fossil fuels, so if you add up the oil, natural gas, and coal, you get around 65%, which is significantly lower than the United States, which is about 82% of its energy consumption comes from fossil fuels. I would say the world is somewhere in that neighborhood too. We're quite lucky. The reason we're a little bit lower on our fossil fuel dependence is because of our abundance of hydroelectricity in Canada. Just as a detail, I mentioned earlier that Canada exports about a third of its energy production and most of that goes to the United States. This chart doesn't include energy production. It's just, so it doesn't include the exports. It's just the consumption at the country level. It's interesting to note that despite all the hype, these renewables, wind, solar, biomass, tidal, they only represent a really small chunk of our energy consumption at the moment. It's interesting that when I started teaching this course about, 2 decades ago now almost, this slice was almost non-existent. It was not even, much less than 1%. And so wind and solar are particularly growing fast, with wind being the bigger component than solar. So that's an overview of how we use, or of what kinds of energy we use in Canada. Now I've got another slide, another one of these landscape slides. Okay, this is the annual energy flow from source to use. This is United States. This is taken from your book. It's figure 1.13. I found a more up-to-date one at the EIA, and it's in QBTUs. Don't worry about it. That's just energy. A little bit old, but the general pattern doesn't change a whole lot. This is called a Sankey diagram, Sankey, after probably Mr. Sankey, I'm guessing, who invented this. And it shows energy sources coming in and how it's used going out. And as it turns out, this is they almost use 100 QBTUs. So these are almost percentages if you add them up, because their total consumption is almost 100 QBTUs, 97.3. So you can look at these as roughly as in round numbers as percentages. So what you have is energy coming in. So coal, natural gas, crude oil, they have all the same sources that we do in different proportions. They have nuclear power, NGPL, or natural gas plant liquids. Those are things like propane. I'll talk about where natural gas plant liquids come from, where propane comes from later on. There's their renewable energy here, 9.2 1.24, which looks large, but you got to remember that includes hydroelectricity. So that's their total renewables, including hydro. The big thing to notice here for the United States is this is their petroleum imports. They import, or back in 2011 they imported about a third of their energy supply from something like that in terms of petroleum from abroad, a lot of it from Canada. And so the U.S. Is not energy independent. They're probably more energy independent now because of fracking, and we'll talk about fracking for oil when we get later on in the course. So when you add it all up, they're about 82% fossil fuel dependent. And so that's the input side. Let's look at the output side over here, where how the energy gets used. So here we have the thing I'd like you to take away from this, because there's a heck of a lot of numbers here, just the broad patterns. Residential and commercial buildings here, they represent about a third of energy usage. So to heat residential and commercial buildings, domestic hot water, and all the electricity use, appliances and that are used inside buildings. So about a third for buildings, about a third in round numbers, not exactly, but about a third for industry, to power industry, to keep the industrial economy going, and about a third for transportation, planes, trains, and automobiles, that sort of thing. So these three big, broad sectors to keep in mind. So if you're a politician and you're thinking about how you're going to deal with climate change, you have to attack energy use in each one of those areas. Now, I couldn't find a Sankey diagram for Canada, so I just found a pie chart. This is at the National Energy Board. Again, a little old, but you get the idea. This is the main concepts. Exact numbers are not important. It's the broad concepts. So the three big sectors would be industrial, transportation, and residential and commercial buildings here. And they've included pipelines in here for some reason. It's probably a fairly small amount of usage, I would say. But residential and commercial buildings, 28, transportation, 25. And Canada has a pretty heavy industrial energy use. We have a lot of pulp and paper and mining and heavy industry. But the same sort of pattern you can see here and in the United States. There's these three big sectors. And if you want to know how it breaks down, like if you want to find out at some point in your life about how the transportation, this 25% breaks down, you can get the details at the National Energy Board. And I've just written a couple of little things here, like freight. So transportation of goods is about 41% of energy use in transportation, and about 59 when I looked this up, it was for passenger vehicles. And you can get the details on, what kind of passenger vehicles, trucks and things like that at the National Energy Board. So that's the pattern of energy use by sector in Canada. Remember, the takeaway is those three broad sectors: transportation, buildings, and industry. Okay, next I'd like to talk about Canada's production of electricity. Of course, electricity is vital to our technological society, and we consume a lot of energy in the production of electricity. So, as I mentioned earlier, we still use some coal for electricity production. Not in Ontario anymore. We phased out coal in 2014, but particularly in Saskatchewan and Alberta, they burn a low grade of coal called lignite, and we'll get into that. So there's a desire to phase out that portion of electricity generation because of its environmental impacts. Across Canada, we do use a lot of natural gas for electricity generation. Now, it says here gas, oil, and others, but oil is pretty expensive to generate electricity with. So this is almost all natural gas, this 10%. We have 15% of our electricity comes from nuclear power. Almost all of that is on Ontario. So we have 2 nuclear power plants at Bruce Nuclear on Lake Huron. And we have Pickering and Darlington on Lake Ontario. And there is also a nuclear power plant, another CANDU nuclear power plant in the East Coast in New Brunswick. Canada is, as I mentioned, a huge well, we have a huge supply of hydroelectric electricity. We're the world's third largest producer of hydroelectricity after, I think it's China and Brazil. So that's mainly in Quebec. A lot of hydroelectricity in Quebec in what's called the James Bay Project. We'll talk about that when we get to the hydroelectricity portion of the course. There's hydroelectricity, and a lot of it generated in BC, Manitoba, and Alberta as well. And of course, we do have some non-hydro renewables, wind, solar, and biomass. So that'd be like burning wood, burning trees, and tidal. We do have a tidal power plant in the east coast of Canada. I would point out that wind is the biggest by far. Wind is about 10 times more, produces about 10 times more electricity in Canada than solar photovoltaic. We're going to talk about all of these electricity generation methods in some detail as we progress through the course. So we'll explain some of the technology in relatively easy terms. This is the world energy consumption of just fossil fuels. You can imagine there's other sources as well, but as I mentioned, about 82% of the world's energy consumption is still fossil fuels, and unfortunately it's not going down, and it's been increasing dramatically. This is a graph of the world energy use in terawatt hours. Don't worry about the units. That's an energy unit going from 1800s to near the present time, and you can see coal, oil, and natural gas growing what's called exponentially. We'll talk about exponential growth in the next presentation. So it's been growing at about 2% per year. This is Canada's energy consumption. Again, crazy units sometimes. These are kilotons of oil equivalent. Don't worry about it. It's just energy use versus time going from the 1960s to almost the present time, but not quite. Our energy consumption has tripled over the past 50 years. It's been growing greater than the world average. Has been growing at about 2.4%. And one of the reasons, of course, is population increase, but also even at a per capita level, our energy consumption is going up, and that's primarily associated with improved lifestyle and affluence. The more affluent we are, the more energy we use, and I discussed that linkage earlier. Okay, I'm going to go to another one of these landscape slides. Okay, this one's pretty busy. It's taken from your textbook. This is energy consumption in the United States. This sort of describes how we got into the current situation, going from the beginning of the industrial age, let's say 1850, up to, well, not quite the present time. And these are the different sources: coal, oil, natural gas, hydroelectricity, etc. So this is energy consumption on the vertical axis versus time. And I want to point out that this is what's called a logarithmic axis. So the scale is not linear. So going an even spacing on this goes up by a factor of 10. So that's 1 to 10, and that's 10 to 100. And when you have this kind of graph that's logarithmic, if you plot an exponential growth, so something that's growing at 2% per year, you get a straight, or 2.6% per year, you get a straight line. So U.S. energy usage has been growing at about 2.6% per year. So, and it's grown by a factor of 50 over the last 150 years, so quite substantially. So let's look at 1850. So 1850, we had coal and wood. That represented the total. Well, pretty much the only sources of energy, a lot of wood. And wood has declined over time. We don't use very much wood for energy generation now, but we use a lot of coal. And, back here, we would have used coal for transportation, for steam engines. So coal use really started to grow in the 1700s with the invention of the steam engine. But this coal use now is, even up here, is in modern times is used for electricity generation. And it has environmental impacts that we're going to talk about. We want to get rid of coal if we can. But coal remains a key resource, even though we tend to think of it as a sort of a Victorian power source. It's still very much a modern thing. Look at oil and natural gas here. Oil and natural gas entered the scene in the late 1800s. So the first oil and gas wells in the United States were in the late 1800s. Of course, we had the the fission bomb in the World War II in the 40s. the generation or the development of commercial nuclear power, the technology was developed in the 50s and 60s. And then with the early 60s, we see the commercial fission nuclear power providing some energy to the society. Geothermal started in about the 80s. And now we're waiting on, hopefully, fusion energy, which is another type of nuclear energy. It's one of the course projects. So if you would like to learn more about that, it's on the horizon. It doesn't currently provide any power to the world, but it may do so in the next decade or so. We're hopeful because it's a very clean source of nuclear power. So if you're interested in that, you might think about it as a fairly more technically difficult project. But if you're interested in that, you could do your project on nuclear fusion. Okay, as I discussed earlier, North Americans, Canadians are affluent, and that affluence translates into high energy use. This is a graph of per capita energy use, so energy use per person for various countries. And you can see that Canada ranks near the top of the world in energy use per person. Now, I think we're not actually the worst. I think it's something like United Arab Emirates that might be a bit worse, but we're still, nevertheless, we're in the certainly in the near the top in per capita energy use. Now, you might wonder why. So why do Canadians use so much energy? So you might pause the video here and try and make a little list before I go through it. Okay, so here are the main points that I see. Of course, we just talked about it. Affluence, high standard of living. We live in a consumer economy, and everything that we buy, you think about it, your car, your jet ski, your new computer, your television, everything uses energy. So that's part of the story. We also have a cultural preference to live in detached single-family dwellings, which consume more energy to heat, and they tend to be large family dwellings. That brings us to the fact that we live in a cold climate, so we have a winter heating problem, which takes energy. Space heating represents about 60% of residential energy usage, so it's a significant factor, although I would point out that Scandinavian countries and some Northern European countries have this same issue, and they're much more energy efficient than we are, so we can't completely blame it on our cold climate. It is true that relative to Europe, we have relatively large distances between urban centers, so we have a low population density, so we use a lot of energy transporting goods and people between our population centers. And that explains a little bit of why we use so much energy. I mentioned earlier when we talked about the three sectors that we have a particularly heavy industrial base in Canada, pulp and paper, mining, that sort of thing. So we use a lot of energy in the industrial sector, which translates, when you divide it by the population, it's going to give you a high per capita energy use. And I would argue, too, that energy is still cheap. We don't tax energy in North America as steeply as they do in Europe, and cheap energy encourages inefficient use, and it makes greener alternatives more difficult for them to compete. And I created a graph here. I did this a few years ago. This is a cost of gasoline to drive 100 kilometers in a car, going all the way back to almost the 1960s to not quite present time. I did this in 2013, I think. So I looked up the cost of gasoline over time. I looked up the fuel efficiency of the vehicles. Vehicles have generally got more efficient over time, although recently with SUVs, perhaps a little bit less efficient. So it's corrected for the price of gasoline, is corrected for the efficiency of the vehicles getting better, and it's corrected for inflation. So this, on the vertical axis here, we have the cost in constant $2011. So it's corrected for the fact that, money gets worth less as you move on in time. And you can see that over time, it's cost about, somewhere around $8 to $10 to drive 100 kilometers. It hasn't changed significantly for decades and decades. And so it's relatively cheap. Gasoline is relatively cheap. And think about it this way. You can buy a liter of gasoline today for about $1. And yet, if you go to buy a liter of bottled water, how much would you pay? So think of it that way. Gasoline, which is, has to be processed and delivered to you, is relatively cheap in North America. And that promotes, I would argue, inefficient usage. Okay, that completes part 1 of the introduction. Have a look at chapter 1, pages 1 through 30 in the textbook, please.